Hey guys, welcome back to the next part of our series. We're almost approaching the end of this, so let's get to it. This is Mesh Part 2. We're back here in Maya. This is a new scene, and I want to show you another of the cool things about Mesh. We're going to talk about dynamics now. Dynamics is one of the very cool things that Mesh has. Now, dynamics is when we animate something in such a way that we don't have to think about what we're animating. We just let the forces of gravity, wind, pushes, and stuff do their work, right? So let's say we want to animate like a Jenga tower. So I'm going to start here with a little small block here. Let's create a little block. And what I'm going to do is I'm just going to create a little bit of a tower here. So there's two things in which, or actually before we do the tower, let's start with just a cube just to show you how dynamics work. So this is going to be my base cube. I'm going to jump into Mesh and I'm going to click here, Mesh Network. There we go. And if I go into the Mesh Distribute, we can create like a little bit of a wall of cubes. So let's say we want, instead of linear, we want this to be a grid. And I don't want any on C. So it's just going to be like 1 on C. And on Y, I do want a couple more, let's say like 5. The distance in Y should be a little bit higher. So something like this, just a small stack of boxes, right? So this thing right here, we can turn into a dynamics network by just going into the options here, clicking this option and saying dynamics. So by doing that, automatically we're going to get a floor down here, and these guys are going to be affected by the forces of gravity. The gravity is coming from this solver called the bullet solver that tells us that right now we have a negative 9.8 force. So if we were to press this, we can see how the boxes fall, and once they hit the ground, they just start like rolling away. Now, every time we're working with dynamics, we're going to be talking about attributes and parameters that we're going to be changing. The downside to working with dynamics and any sort of like a simulated effect is that we need to be very precise in how we set up everything so that we get the results that we're expecting. So for instance, maybe I don't want these guys to fall that low and then just bounce like that. So I'm going to go here onto my bullet solver, and there's this option here called the ground. You can see that the position is -20. Let's say -5. That way the things are just gonna fall a little bit. Whoop. Let's see. There we go. So they just fall a little bit there and they just stand there. They're not gonna slide or anything because there's not enough force to really push them, right? Now the cool thing about this is that this is again dynamic. So if I were to go back to the Mesh Distribute and say, hey, you know what? I thought about it and now I do want a couple more boxes here with maybe a little bit of a less distance or more distance, whatever works for me. I can now see what's going to happen when all of these boxes go into this array. So very, very cool, right? Now, another thing we can do is we can add elements that interact with these objects. So if I were to move this whole tower here and I were to add, like, let's say a cube, like a little plane here, let's say something like this. Let's rotate it so that it's an obstacle pretty much. What I can do now is I can just grab this guy, go into the bullet solver, middle mouse drag and drop here in the collider objects, and now this object, this cube that I just created, is going to create a collision with all of these objects, and look at what happens now. Pretty cool, right? Now the only issue here, as you can see, is that all of the cubes are falling and kind of like sliding as if there was like oil or soap or something. That's because the objects here on the Mesh Dynamics have very little friction. So I'm going to increase the friction, and that's going to allow it to stay a little bit closer to the center. As you can see, they don't slide as much because the friction is not allowing them to slide. We also have the damping here that we can increase. That's also going to reduce some of the movement. As you can see, the simulation is going to be way more solid. Now this also appears back here in the bullet solver. So the floor itself actually has friction, so let's increase the friction on the floor. That way when these things fall, they pretty much remain on the same position, in the same place. They're not gonna slide anymore. And you can let this animation run its course as long as you want. Maya is gonna start calculating what's happening throughout the whole thing. So dynamics are really cool again because they will allow us to create this certain elements that would be a little bit difficult to do in a manual way. Like if we would try to manually animate each of these cubes falling and stuff, it would be very, very difficult. Now, sometimes I'd like to increase the gravity all the way to like minus 98. This is a little bit closer to, let's go here, minus 98. This is a little bit closer to Earth's gravity. So you're gonna see that the things fall in a very nice way. The only problem is that it's so strong that it's trying to push through the ground, and we're getting this. We can, of course, reduce the bounce on the floor, and if we go into the repro mesh here, we can also reduce the bounce. Let's see if that helps. Not really. It's just that the gravity is way too strong. So I'm just gonna have to like bring it back to minus 9.8. There we go. So it kind of looks like they're falling in slow motion. It's not like if they were falling in the real world, but again, you can see it's pretty cool. Now that's not only that's not the only thing. We can actually add more objects that interact with the elements in a more dynamic way. So let's imagine, let's add more cubes. Hopefully this doesn't break my computer. You definitely do need a little bit more memory than usual for this kind of thing. So the more cubes you're animating, the more intense this is gonna be for your computer. I'm gonna create a sphere, and I'm just gonna make the sphere go from down here in a very fast way. Let's say after the cubes are kind of settled, like frame 80, in a very fast way, the sphere is just gonna like bloop, go all the way up. And again, we can actually hide the sphere. We don't need to see the sphere. And as long as we add this to the bullet solver with middle mouse and drag into here, it should affect the cubes. Let's see. Boom. There we go. Now, the only problem with movements that are really fast is that you're going to need a little bit more collision iterations here. So I'm going to increase this to 20. That's pretty much telling the thing that I wanted to really analyze what's going on so that we get the best possible effect. Another way to make this example a little bit easier to visualize is, of course, if we go to the sphere and we make the movement a little bit slower so that we give a little bit more time for the process to actually analyze what's going on. There we go. See that? Very cool, right? So mesh networks are really nice because, as you can see, we get this very cool effect. Now let's build a little bit of a tower. So what I'm gonna do here is I am gonna delete all of this. Back to the beginning. Let's go here and let's create a little bit of a tower, like a Jenga tower. So we do here. There we go. And I am gonna make this a mesh network. So mesh network. You can see that we hit the original cube. We're gonna go back to a grid distribution. There we go. It's gonna be 3 by 3. That's fine. And we want this to be quite high. So let's add like, yeah, let's do 5 floors. And no elements on C. Just the one. So I'm gonna increase the space here, because what I'm gonna do is I am gonna duplicate this guy. I'm gonna duplicate the network. I'm gonna have a separate mesh network. And now this new network, what I'm gonna do is I'm gonna use a transform node inside of the network to move the whole network into a different position. So if I grab this transform node right here, I can say, you know what? I wanna move you on the y-axis 10 units up. That's way too much. Let's say 2 units up. That's too little. 1 unit up. There we go. 1 unit is fine. And then I want to rotate the whole thing on the y-axis 90 degrees. So as you can see, we get this very nice effect where we're creating the little tower, but we're doing it with 2 mesh networks. This is just one way to do it. There's always more ways to do it. Now let's say 0.5 on X. Probably 1 on X or 1.5. I want to align this as close as possible to the original. There we go. And then on C, it's 2.5 as well, or minus 2.5. There we go. Now on each of these guys, I'm going to add a dynamics node. It's the same bullet solver for both of them. That's good. Like we don't have several bullet solvers, just one solver, and each network has its own element. Let's move the position of the floor to like -5 again. And if we hit play, you can see that the whole tower just goes and assembles itself in very nicely, right? We can, of course, go to each of the dynamics here. Let's increase the friction for both of them to like 0.5. There we go. So now the blocks shouldn't slide as much. And we just built a small Lego tower that is ready to be destroyed with like a sphere or something. So let's go again here with a sphere. Let's go with a big sphere right here. We're gonna go, let's say here, and then just like bloop, move the whole thing. We go to the bullet solver and we add this thing right here. And now if we hit play, the tower falls, and a couple frames later, this thing just like rolls through it and destroys the whole element, creating this very nice pile-off effect. Now, Mesh is not only good for animation, like you can of course use this like we're doing here for this example, but there's other things that Mesh is really good at. I actually use Mesh for modeling quite a bit. If I'm doing like a lot of rubble and stuff, this destruction allows me to create like very random things very fast. So let's say you want to add just like bricks laying all over the place, you can use a mesh network like this and create an animation until you get something that looks destroyed and nice, and then you just, once you have something that you like, for instance, let's say like I like this thing like getting exploded like this, just grab both repro meshes and Control D, duplicate them, and these guys are a completely new geometry that's not attached to the actual like element here. So again, if we find like another one, like let's say I like this one, just grab the repro meshes again, Control D, and we're gonna be able to create some very crazy looking elements very, very fast, like some very abstract shapes here, very nicely, right? So Mesh and a lot of tools inside of Maya are very useful also to create other types of things that are not only animation. So that's it for this one, guys. Just a quick introduction to Dynamics. Again, I invite you to try it out, try to find a way and incorporate it into a small like promo video or something. We can of course add this sort of things to all of the animations that we did before. So remember the baseball one, maybe we want to create like a little bit of a wall and he's gonna break the wall with a sphere. We can do a lot of things. So feel free to experiment with all of these tools. And I'll see you back on the next video for our final Mesh video. So hang on tight and I'll see you back on the next one. Bye-bye.